Hi, and welcome back. This is section 3, and we're going to give you a quick, high-level overview of machine learning terminology and a typical workflow. We will cover these topics in more detail later in this course, but for now, we'll focus on the larger picture. So to begin, you should always start with the business problem you or your team believe could benefit from machine learning. From there, you want to do some problem formulation. In this phase, one task is to articulate your business problem and convert it to an ML problem. After you've formulated the problem, you move on to the data preparation and pre-processing phase. You'll pull data from one or more data sources. These data sources might have differences in data or types that need to be reconciled so you can form a single cohesive view of your data. You'll need to visualize your data and use statistics to determine if the data is consistent and can be used for machine learning. We'll look at some of the data sources later in the course. This example data has 4 columns containing data from 3 different data sources. The sources had slightly different ways of representing data, and the results are shown in the table. In ML problems, columns represent features, and rows represent instances. There are some issues here with the data in some of the instances. In some cases, you'll need a subject matter expert or a functional expert to understand the authenticity of the data. For example, the date that's represented as 11/2/1969 could be November 2nd or February 11th in the year 1969. Someone who owns or manages the data pool would be able to clarify this ambiguity. Also, the word male can probably be attributed to an import issue where cells shifted position. But there could be an outside chance where it's the actual location, Male, a city that's the capital of the Republic of Maldives. At times, this error identification isn't as simple, and you'll need an SME to review the data. You'll learn about the role of experts later in this course. Remember that one of the largest impacts you can have on the success of a machine learning project is to have consistent and correct data. After your data is in good shape, it's time to train your model. This is where the process gets very iterative and fluid. You'll likely go through many multiple passes of feature engineering, training, evaluating, and tuning before you find a model that meets your business goals. Feature engineering is the process of selecting or creating the features your model will be trained with. Features are the columns of data you have in your data set. The goal of the model is to correctly estimate the target value for the new data. The ML algorithm will use the features to predict the target. In this example, the target data is the average number of steps taken in a week. Selecting the correct features can involve adding, removing, or calculating new features. You might want to make the data formats consistent. The consistent formats could be later used in the model, or you can make these changes for cosmetic reasons. Depending on the problem you want to solve with this data, you might not even need to include the name feature in the example data. What about the country feature? If this were a traditional database, you might want to move country to a lookup table, then reference it. Most ML algorithms want the data for an instance in a single row. ML algorithms need numerical data to process. You could consider turning the country text into the country's ISO code. However, the model might interpret the numerical value as having meaning. So the UK's ISO code value of 44 would be more significant than the ISO code value of the US, which is 01. In this case, splitting the data into multiple columns is fine. This is known as categorical encoding, and you'll learn about this later in the course. For other types of data, you could convert the text value into a numerical value. For example, you could use 0 or 1 to represent male or female. These numeric values can be used more easily by the model. What about the remaining features like age, birth month, which is shown as BM in the table, or day of week, which is shown as DOW? Extracting the age, birth month, and day of week might be appropriate depending on the problem you're trying to solve. Does age impact the target variable? What about which day of the week they were born on? Don't worry if this sounds complicated. You'll learn more about feature engineering later in this course. After your data is cleaned and you've identified the features you want to use, it's time to train a model. You won't use all the data to train your model. In fact, you need to hold some of the data so you have some data to test with. Typically, you'll use about 80% of the data to train with, and you'll save the rest of the data for testing. Next, you'll train a model with training data. In the diagram, the model uses the XGBoost algorithm. The model itself has some parameters you can set. These parameters will alter how the algorithm works, and they're known as hyperparameters. The output of the training job will be a trained model. With the trained model, you can use some of the test data to see how well the model performs. You'll take an instance the model hasn't seen and use it to perform a prediction. Because you already know the target in your test data, you can compare the two values. From these comparisons, you can calculate metrics, which give you data on how well the model is performing. You'll then make changes to the model's data, features, or hyperparameters until you find the model that yields the best results. When training your model, there's a real danger of overfitting or underfitting the model. Your model is overfitting your training data when you see the model performs well on the training data but doesn't perform well on the evaluation data. This is because the model is memorizing the data it saw and can't generalize to unseen examples. Your model is underfitting the training data when the model performs poorly on the training data. This is because the model can't capture the relationship between the input examples, which are often called X, and the target values, which are often called Y. Understanding model fit is important for understanding the root cause of poor model accuracy. This understanding will guide you to take corrective steps. You can determine whether a predictive model is underfitting or overfitting the training data by looking at the prediction error on the training data and the evaluation data. We'll show you steps you can take to avoid this later in this course. After you've retrained the model and you're satisfied with the results, you deploy your model to deliver the best possible predictions. Later in this course, we'll walk you through these different phases and give you hands-on experience with each of them. But knowing the process is also useful when using the managed services we'll also explore later, where certain Amazon ML services will do the bulk of the work for you. Here are some of the key takeaways for this section. First, we looked at how the machine learning pipeline process can guide you through the process of training and evaluating a model. The iterative process can be broken into three broad steps: data processing, model training, and model evaluation. That's it for this video. We'll see you in the next one. Welcome back. In this section, we'll look at some of the tools you'll be using throughout the rest of this course. Before we start, this list isn't an exhaustive list of all the tools available today. We're only going to cover them at a high level, but it's a good place to get started. First, there's the Jupyter Notebook. The Jupyter Notebook is an open source web application you can use to create and share documents that contain live code, equations, visualizations, and narrative text. Uses include data cleaning and transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more. Jupyter Lab is a web-based interactive development environment for Jupyter notebooks, code, and data. Jupyter Lab is flexible. You can use it to configure and arrange the user interface to support a wide range of workflows in data science, scientific computing, and machine learning. Jupyter Lab is extensible and modular. You can write plugins that add new components and integrate with existing ones. Later in this course, you'll use Amazon SageMaker, which hosts both Jupyter Notebooks and Jupyter Lab. Pandas is an open source Python library. It's used for data handling and analysis. Pandas represents data in a table similar to a spreadsheet. This table is known as a Pandas data frame. Matplotlib is a Python library for creating scientific, static, animated, and interactive visualizations in Python. You'll use it to generate plots of your data later in this course. Seaborn is another data visualization library for Python that's built on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphs. NumPy is one of the fundamental scientific computing packages in Python. It contains functions for n-dimensional array objects. It also has useful math functions such as linear algebra, Fourier transform, and random number capabilities. Scikit-learn is an open-source machine learning library that supports supervised and unsupervised learning. It also provides various tools for model fitting, data pre-processing, model selection and evaluation, and many other utilities. Scikit-learn is built on NumPy, SciPy, and Matplotlib. It's a good tool for exploring machine learning. Although you'll only use it to borrow a few functions in this course, you might want to consider exploring it after you complete this course. Moving up from individual libraries and packages, there are also tools that contain production-ready frameworks. We already mentioned Scikit-learn, which is a good library for machine learning. The frameworks supported on AWS, such as TensorFlow and Keras, also include libraries you can use for machine learning. All the frameworks listed here are supported on AWS and can be used from Amazon SageMaker. AWS also provides compute instances that are tuned for machine learning in both the cloud and at the edge. Compute instances can be optimized for learning and inference. Another AWS resource you can use are certain Amazon Machine Images, or AMIs. We offer pre-packaged AMIs that contain many of the popular frameworks. Finally, there's Amazon SageMaker, which is an AWS service with many capabilities. First, SageMaker can deploy machine learning instances running Jupyter Notebooks and Jupyter Lab. It manages the deployment of these compute resources, so you only need to connect to the Jupyter environment. SageMaker also provides tools for labeling data, training models, and hosting trained models. AWS Marketplace also provides a selection of ready-to-use model packages and algorithms from third-party machine learning developers. AWS also provides a set of managed machine learning services, and you can integrate them into your applications even if you don't have substantial machine learning experience. For computer vision, Amazon Rekognition provides object and facial recognition for both image and video. Also, Amazon Textract can extract text from images. Speech services include Amazon Polly, which can speak text. Another speech service is Amazon Transcribe, which converts spoken audio to text. For language, Amazon Comprehend uses NLP to find insights and relationships in text. Also, Amazon Translate can translate text into different languages. If you want to work with chatbots, Amazon Lex helps you build interactive conversational applications that use voice or text. For forecasting, Amazon Forecast uses machine learning to combine time series data with additional variables so you can build forecasts. And finally, if you'd like to work with recommendations, Amazon Personalize can help you create individual, personalized recommendations for customers. These managed services have already been trained in many aspects of the problem domain. You only need to provide your specific data to get started. We're going to look at many of these managed services in the second half of this course, after you learn how to do things on your own. The key takeaways for this section include these points. First, Python is the most popular language for performing machine learning tasks. Jupyter Notebooks provide you with a web-based hosted development environment for machine learning. You'll use Jupyter Notebooks frequently in machine learning. There are a large number of open source tools, such as Pandas, that you'll use often as a machine learning practitioner. Finally, depending upon your requirements, you might start with low-level frameworks to create your own solution. You might also use tools such as Amazon SageMaker to help with some of the heavy lifting. Or you could simply use and adapt one of the managed Amazon ML services for your specific problem domain. That's it for this video.